Hello, my name is José Carracedo. I'm from Universidad Autónoma de Querétaro, and I am presenting the poster called The Network of Aging and the Myth of Oxidative Stress, a Boolean Approach. Aging is a multifactorial process, and the model organism C. elegans have been used to describe many genes responsible for lifespan regulation. One of them is CLK1, a precursor of ubiquinone. The mutant of this gene can extend the lifespan of this worm almost in twofold. And many processes are involved in this mutant's lifespan extension, but their relationship and influence are unknown. Here we build a novel Boolean network to explain these interactions and their effects on lifespan and healthspan through neuromuscular behavior assays in different mutant strains. Here is the network. It is composed of 25 nodes that represent multiple elements like transcription factors, kinases, enzymes, and cellular processes. One of the most important nodes are associated with autophagy and lipid metabolism. In the top right of the network, we can see an interesting loop between ROS HIF1 and the AMPK kinase. This interaction is curious because a double mutant of CLK1 with AQ2, the alpha subunit of AMPK, reduces the lifespan of CLK1 to wild-type condition, as we can see in the right graph. Now the network attractors show what we expect when CLK1 is active. There are one-state attractors where enhanced autophagy and lipid metabolism are always off. However, when CLK1 is inactive, a cyclic attractor continuously turns on and off enhanced autophagy and lipid metabolism. In the left side, we can see the one-state attractors when CLK1 is active, and in the right side, we can see the six-state attractor when CLK1 is inactive. Then we compute the Derrida curve based on the Hamming distance, and we can see that the system is in a chaotic regime, the same as small networks, just like the cell cycle network that we can see in the right side. We expect a more extensive network will show a critical state in the curve, this including all the redundant elements, intermediate elements, and other pathways like food restriction and insulin pathway. Finally, here we see the pharyngeal pumping behavior in the left side and the swimming behavior in the right side. The rate of these behaviors is different in time and strains, and the long-lived CLK1 strain has a slow rate in both behaviors in comparison to the other strains. This slow rate be probably a consequence of the homeostasis regulation seen in the network. The next step is to generate a double mutant of CLK1 and AMPK, and see other behaviors like egg laying and autofluorescence to define the health span conditions and their relation with the attractors, as well as the analysis of EFP transgene strains to check the change in processes like autophagy and lipolysis. And that's all. Thanks for your attention.